placed. In the receptacle or case containing that drum, let one hole be opened with a small pipe attached, through which a stone, as soon as the obstruction is removed, falls with a ringing sound into a bronze vessel. 7. So, when the ship is making headway, whether under oars or under a gale of wind, the floatboards on the wheels will strike against the water and be driven violently back, thus turning the wheels, and they, revolving, will move the axle, and the axle the drum, the tooth of which, as it goes round, strikes one of the teeth of the second drum at each revolution, and makes it turn a little. So, when the floatboards have caused the wheels to revolve 400 times, this drum, having turned round once, will strike a tooth of the horizontal drum with the tooth that is fixed to its side. Hence, every time the turning of the horizontal drum brings a stone to a hole, it will let the stone out through the pipe. Thus, by the sound and the number, the length of the voyage will be shown in miles. I have described how to make things that may be provided for use and amusement in times that are peaceful and without fear. Chapter 10. Catapults or scorpiones. 1. I shall next explain the symmetrical principles on which scorpiones and ballistae may be constructed, inventions devised for defense against danger and in the interest of self-preservation. The proportions of these engines are all computed from the given length of the arrow which the engine is intended to throw, and the size of the holes in the capitals, through which the twisted sinews that hold the arms are stretched, is 1/9 of that length. 2. The height and breadth of the capital itself must then conform to the size of the holes. The boards at the top and bottom of the capital, which are called peritreti, should be in thickness equal to one hole, and in breadth to 1 3/4, except at their extremities, where they equal 1 hole and a half. The side posts on the right and left should be 4 holes high, excluding the tenons, and 5/12 of a hole thick, the tenons half a hole. The distance from a side post to the hole is 1/4 of a hole, and it is also 1/4 of a hole from the hole to the post in the middle. The breadth of the post in the middle is equal to 1 hole and 1/8, the thickness to 1 hole. 3. The opening in the middle post, where the arrow is laid, is equal to 1/4 of the hole. The 4 surrounding corners should have iron plates nailed to their sides and faces, or should be studded with bronze pins and nails. The pipe, called Vii-x in Greek, has a length of 19 holes. The strips, which some term cheeks, nailed at the right and left of the pipe, have a length of 19 holes and a height and thickness of 1 hole. 2 other strips enclosing the windlass are nailed on to these, 3 holes long and half a hole in breadth. The cheek nailed on to them, named the bench, or by some the box, and made fast by means of the dovetail tenons, is 1 hole thick and 7/12 of a hole in height. The length of the windlass is equal to holes, the thickness of the windlass to 3/4 of a hole. 4. The latch is 7/12 of a hole in length and 1/4 in thickness, so also its socket piece. The trigger or handle is 3 holes in length and 3/4 of a hole in breadth and thickness. The trough in the pipe is 16 holes in length, 1/4 of a hole in thickness, and 3/4 in height. The base of the standard on the ground is equal to 8 holes. The breadth of the standard where it is fastened into the plinth is 3/4 of a hole, its thickness 2/3 of a hole. The height of the standard up to the tenon is 12 holes, its breadth 3/4 of a hole, and its thickness 2/3. It has 3 struts, each 9 holes in length, half a hole in breadth, and 5/12 in thickness. The tenon is 1 hole in length, and the head of the standard 1 hole and a half in length. 5. The antefix has the breadth of a hole and 1/8, and the thickness of 1 hole. The smaller support, which is behind, termed in Greek antibasis, is 8 holes long, 3/4 of a hole broad, and 2/3 thick. Its prop is 12 holes long, and has the same breadth and thickness as the smaller support just mentioned. Above the smaller support is its socket piece, or what is called the cushion, 2½ holes long, 1½ high, and 3/4 of a hole broad. The windlass cup is 2 7/12 holes long, 2/3 of a hole thick, and 3/4 broad. The cross pieces with their tenons have the length of holes, the breadth of 3/4, and the thickness of 2/3 of a hole. The length of an arm is 7 holes, its thickness at its base 2/3 of a hole, and at its end 1/2 a hole. Its curvature is equal to 2/3 of a hole. 6. These engines are constructed according to these proportions or with additions or diminutions. For, if the height of the capitals is greater than the width, when they are called high tensioned, something should be taken from the arms, so that the more the tension is weakened by height of the capitals, the more the strength of the blow is increased by shortness of the arms. But if the capital is less high, when the term low tensioned is used, the arms, on account of the strength, should be made a little longer, so that they may be drawn easily. Just as it takes 4 men to raise a load with a lever 5 feet long, and only 2 men to lift the same load with a 10-foot lever, so the longer the arms, the easier they are to draw, and the shorter, the harder. I have now spoken of the principles applicable to the parts and proportions of catapults. End of Book 10, Chapter 10.